Hi everyone, myself N. Arun Kumar from SNS College of Technology in the Department of ECE. In this video, we are going to see about step response analysis of second order systems. These are all the slides we are going to see in this video: introduction, second order systems, developing solutions, activity, and followed by assessments. Challenges. Many of them are confused about first order system and second order system because both are same. The only slight changes is frequency, because the frequency of the corresponding system is represented by omega n and omega n square. If you are having first order system, it will be represented as omega n, and if it is in a second order system, then it can be represented by omega n square. So like this, the equation has been generated based on the type of the systems and definitions. So here the step response analysis of the second order system or first order system is based on four damping ratio of the conditions. So the damping ratio means actual output to the desired output, the ratio of actual output and the desired output, because we will get the output as what we are expecting the output is. We may define based on the damping ratio of the corresponding second order systems. If it is differ, then we need to cross verify the corresponding damping ratio of the conditions. The damping ratio is based on overdamp del greater than 1 and underdamped 0 del 0 less than 1 and undamped del equal to 0 and critical damp del equal to 1. So these the conditions which will be satisfied of the corresponding output of the transfer function. So these things can be represented as a second order response specifications, because almost we are having a greater than 1, less than 1 and 0 conditions. So all the values has been plotted here. If it is reached greater than 1, then it is considered as a critically damped. It may be reached up to 2% or maximum 2 level. The time domain specifications, these things will be represented in two type of responses. Either it may be a transient responses and steady state responses. The transient state responses means the define of the condition of the damping conditions, because the damping conditions are represented as a transient responses, and it will be followed up to the steady state responses. While the steady state responses reaches, then the value of the graph will be grow as normally. So the diagram shows that first half TC will be the transient responses and the TA will be acted as a steady state responses. Second order system. So the second order system has been represented, and it will be plotted based on the del value damping ratio of the conditions, as we have seen already in the previous slide. So these values has been plotted by using this normal graph. So the corresponding value as theta, the theta can be calculated based on the damping conditions of the systems, and the theta value has been plotted for the given transfer function of the systems. And developing solutions. Suppose if you are having a different value, different equations means, then we can able to see the corresponding damping ratio of the systems. Here they are listed out undamped system and critically damped conditions. So in undamped systems, they are given the transfer function of the system 9 by s square plus 9. It is the transfer function g of s. Then the value has been plotted based on the equation of the corresponding characteristic equation. So then it will be known as J3 and minus J3, because undamped means del equal to 0. So that it will be occur only in the value of del equal to 0. And for a critical damp condition, it is occur del equal to 1, so the value becomes a equal to 1, so that the minus 3 has been generated for this equation. So the poles has been plotted and the minus 3 value. So like this, all the values has been calculated based on the del value, and if it is calculated, then the same value has been generated up to the steady state responses. For critical damp, it is comes under from minus 3 is the value, so that it will be calculated from 0. Then the steady state responses is reached up to the values of the error of the signals. different damping ratios. Once the values has been calculated and the corresponding plot has been generated, it may be differ based on the del value. Suppose if it is having a del equal to 0.7, then it is comes under below 1. Like this, all those values has been plotted, maximum del equal to 2 values. Mind mapping. So these three things will be define the exact solution of the corresponding second order response of the systems. Activity. So the activity given as group discussion, we need to identify the damping conditions based on the del greater than 1, del equal to 0, del equal to 1, 0 less than del less than 1, so that they know about very well the damping ratio of the corresponding system functions. It maybe take 5 minutes individually, then discuss with your partner, and you can decide, and you can have a chat with your friends, and you can find the solutions of the equations. Assessments. So the critically damped system is preferred in industrial motion control because it produces maximum overshoot or give fastest response or has maximum rise time with solutions or so steady solutions. The answer is give fastest response without solutions, so that we are using this actual critically damped conditions. In underdamped system, the percentage overshoot mainly depends on natural frequency, system gain, damping ratio, and input magnitude. The main condition is damping ratio. It is only define the conditions of the overshoot of the systems. These two references I have taken for this video. Thank you.